Imagine you're locked in a small room. No windows, no way out. Suddenly, a piece of paper slides under the door. It's covered in Chinese symbols. But here's the thing. You don't understand Chinese. Not a single word. But there's hope. Inside the room, you find a massive instruction manual, written in English. This manual doesn't teach you Chinese. It just tells you exactly what to do when you see a certain symbol. If you receive one character, the manual tells you which other symbols to write down as a response. You carefully follow the instructions, copying symbols and arranging them as directed. Once you're done, you slide your response under the door. From the outside, the person receiving your response thinks, "Wow, this person inside really understands Chinese. Your answers are perfectly correct." But do you actually understand Chinese? Of course not. You're just following rules, manipulating symbols without any clue what they mean. This is where we make an important distinction: syntax versus semantics. Syntax is just about following rules, arranging symbols in a specific way, like solving a puzzle. But semantics is about meaning. It's about understanding what those symbols actually represent. In this thought experiment, you've mastered syntax. You can perfectly arrange Chinese symbols, but you completely lack semantics. You have no actual understanding of what you're saying. This is exactly the question posed by philosopher John Searle. When AI processes language, is it really understanding what it's saying? Or is it just like you in the Chinese room, manipulating symbols without meaning? AI systems like chatbots and virtual assistants can generate human-like responses, but do they actually comprehend what they're saying? Or are they just following advanced instructions like our manual in the Chinese room? Think about it. When AI answers a question, is it thinking? Does it have real understanding? Or is it just a sophisticated version of what you were doing, matching input to output, without any awareness of meaning? This is one of the biggest debates in artificial intelligence. Can a machine ever go beyond simulating understanding and actually experience meaning the way humans do? Now, let's dive more deep into Chinese room. Artificial intelligence is getting smarter every day. Chatbots, voice assistants, even AI that can generate art and music. But here's the big question. Can AI ever truly think? Can it actually understand the world like humans do? Philosopher John Searle didn't think so. And to prove it, he came up with one of the most famous thought experiments in the philosophy of mind: the Chinese room. Searle devised the Chinese room to challenge an idea called strong AI. Strong AI is the belief that a computer running the right program doesn't just simulate thinking, it actually understands things, just like a human. But Searle wasn't convinced. He wanted to show that merely following rules, no matter how advanced, isn't enough to have a mind. Let's go back to the Chinese room. Imagine you're locked inside, and you're following a book of instructions to manipulate Chinese symbols. Even though your responses seem perfect, you don't actually understand Chinese. You're just following rules. This is exactly what AI does. It processes symbols, follows patterns, and produces responses. But does it truly grasp the meaning behind those symbols? Searle says no, and that's the core of his argument against strong AI. This debate raises an even bigger question. If computers can only manipulate symbols but never understand their meaning, can they ever have consciousness? Can they ever develop true intentionality, the ability to have thoughts about things, like humans do? Sure, AI can recognize words and images, but does it actually know what they mean? Can it have beliefs, emotions, or experiences? Or is it just an incredibly advanced Chinese room, a system that appears intelligent, but is actually just following rules? This leads us to a bigger, even more controversial question. Can AI ever have a mind? If computers can only manipulate symbols but never understand their meaning, can they ever develop real consciousness? Searle's argument suggests they don't. They are, at best, just advanced versions of the Chinese room systems that seem to understand language but are really just executing rules. But some AI researchers disagree. They argue that as AI becomes more complex, it might eventually cross a threshold where it does develop real understanding. So which side is right? This debate isn't just about AI, it's about what it means to have a mind. If understanding requires more than just following rules, then maybe AI will never truly think like we do. But if intelligence is just a matter of complex computations, then maybe one day, machines really will understand us. Back in the 17th century, philosopher Gottfried Wilhelm Leibniz imagined something fascinating: a giant mechanical mill designed to think like a human mind. He asked, if you walked inside this mill, Seeing all the gears and pulleys working together, would you ever actually find thoughts or consciousness inside it? Leibniz believed the answer was no. No matter how complex the machinery, all you'd see is mechanical processes, never actual understanding or awareness. And this was a crucial insight. Just because a system functions intelligently doesn't mean it experiences intelligence. Centuries later, philosopher Ned Block came up with a new version of this idea, the Chinese nation thought experiment. Imagine that every person in China is given a walkie-talkie, and together they follow a set of instructions to send and receive signals, just like neurons in a brain. With enough organization, the entire Chinese population could function like a giant brain. But here's the question. Would this enormous system actually have a mind? Bloch argued that, just like Leibniz Mill, organizing tiny components into a system that functions like a mind doesn't necessarily mean it has real thoughts. And this is where John Searle's Chinese room enters the picture, bringing this debate straight into the world of artificial intelligence. At the heart of this debate is a major philosophical battle. Functionalism versus Searle's view. Functionalists argue that mental states are defined by their function, not by what they're made of. If something acts like a mind, taking in inputs, processing them, and producing intelligent responses, then it is a mind. This means that, in theory, a machine could have genuine thoughts, emotions, and consciousness if it's arranged in the right way, just like a biological brain. But Searle disagreed. He argued that syntax alone can never produce semantics. Let's go back to the Chinese room. Inside, you're following a set of rules, manipulating symbols, producing perfect responses. To an outsider, it looks like you understand Chinese. But in reality, you don't. You're just moving symbols around, following formal rules, just like a computer running a program. Searle's key point? No matter how sophisticated an AI gets, as long as it's just processing symbols, it will never truly understand the meaning of what it's doing. Strong AI believers say, but if it acts intelligent, isn't that enough? Searle's response: no, because acting intelligent is not the same as being intelligent. AI has come a long way since Searle's thought experiment. Systems like ChatGPT, Google's Bard, and other neural networks generate stunningly realistic language. But does AI understand what it's saying? Or is it just a super advanced Chinese room, manipulating symbols without comprehension? Some AI researchers believe that scale changes everything. If you build a large enough system, like the human brain, true understanding might emerge. But Searle would still argue, no matter how big or complex an AI gets, as long as it's just processing symbols, it lacks real consciousness. The first challenge to Searle's argument is called the system's reply. It says, sure, the person inside the room doesn't understand Chinese. But what if the entire system, the person, the instruction manual, the symbols, together, understands? It's like saying a single neuron in your brain doesn't understand English, but your whole brain does. Searle's response? He says no matter how you define the system, the key point remains. There is still no real understanding happening, just symbol manipulation. To prove it, he says, imagine if you memorized all the rules in the instruction book and did everything in your head without the room or paper. You'd still be following the same process, but you still wouldn't understand Chinese. So if there's no understanding at the individual level, Searle argues, there's no real understanding at the system level either. The next counterargument is the robot reply. It says, the Chinese room is flawed because it's just processing symbols in isolation. But what if we put the system inside a robot that can see, hear, touch, and interact with the world? In other words, maybe understanding requires a physical body, a way to connect words with real-world experiences. Searle's response? He says adding cameras and sensors doesn't change the core problem. The robot would still just be following pre-programmed rules, processing inputs and outputs without truly understanding anything. Think of a self-driving car. It responds to traffic signs, but does it actually know what stop means? Or is it just following programmed rules? Searle says the robot would just be an advanced version of the Chinese room, still trapped in syntax, with no real semantics. Okay, but what if we go even further? What if instead of just processing symbols, we simulate an entire human brain, neuron by neuron? This is called the brain simulator reply. It says, if a system behaves exactly like a real brain, wouldn't it also have real thoughts and understanding? Searle's response? He says even this wouldn't work. Why? Because simulating something isn't the same as being that thing. Imagine a computer perfectly simulating the way a stomach digests food. Now, no matter how detailed the simulation, it won't actually digest anything, It's just running a program. Likewise, even if we simulate a brain, it doesn't mean we've created real thoughts. It's still just a symbolic system running rules, not an actual conscious mind. Here's another challenge. The other mind's reply. We assume other people have minds because of how they behave. If a computer behaves just like a human, why not assume it understands too? Searle's response? He says that's missing the point. Yes, we judge people's understanding by behavior, but that's because we already know humans have minds. With AI, we know it's just following rules. It might appear to understand, but according to Searle, it never actually does. There are even more arguments against Searle's Chinese room, like the virtual mind reply, which says understanding might exist at a higher level even if it's not inside the room. The connectionist reply, which argues that brains work differently from rule-based systems, so neural networks might lead to real understanding. But no matter the argument, Searle always comes back to his core point. Manipulating symbols is not the same as understanding them. In 1980, philosopher John Searle introduced the Chinese room thought experiment. Fast forward to today, and we have AI models like ChatGPT. These systems process vast amounts of text data to generate coherent responses. But does their ability to produce human-like text mean they understand it? Alan Turing proposed the Turing test to assess a machine's ability to exhibit intelligent behavior indistinguishable from a human. However, critics argue that passing this test doesn't equate to genuine understanding. Critics of strong AI, the belief that a suitably programmed computer can possess a mind, contend that current AI systems, even those passing the Turing test, lack true comprehension. They argue that these models operate as advanced, stochastic parrots, generating plausible text without grasping its meaning. Recent discussions have revisited Searle's argument in the context of AI models like ChatGPT. Some scholars suggest that ChatGPT functions as a modern Chinese room, processing inputs to produce outputs without genuine understanding. One paper argues that while ChatGPT can generate human-like responses, it lacks consciousness and intentionality, operating purely on syntactic manipulation. This debate raises profound questions about the nature of understanding and consciousness in machines. Can AI ever move beyond sophisticated symbol manipulation to achieve true comprehension? Or are they destined to remain as advanced simulators without awareness? As AI continues to evolve, these philosophical inquiries become increasingly pertinent, challenging our perceptions of intelligence and the potential of artificial minds. Let's start with the fundamental distinction at the heart of this debate: syntax versus semantics. Computers, like the person in the Chinese room, process syntax. They follow rules to manipulate symbols. But humans don't just manipulate symbols. We understand their semantics, their meaning. Searle argues that even the most sophisticated AI systems, no matter how advanced, are just performing symbolic computations. For example, when AI translates a sentence, it doesn't actually grasp the meaning. It just finds the most statistically probable response based on training data. In contrast, when a person reads the same sentence, they interpret its meaning in a context and relate it to their personal experiences. Searle says this difference between mere rule following and true understanding is why AI, no matter how powerful, does not have a mind. To fully understand Searle's argument, we need to talk about intentionality, a key concept in philosophy of mind. Intentionality is the ability of mental states to be about something, to refer to or represent something beyond themselves. For example, if I think about Paris, my thought is about a real-world city. But when a computer processes the word Paris, it doesn't actually think about the city. It just associates it with other words based on statistical patterns. Searle argues that AI systems lack true intentionality because they don't actually experience thoughts. They just manipulate symbols based on pre-programmed rules. And that's the core of the debate. Can a system that only manipulates symbols ever truly understand? Some argue that AI will never bridge this gap unless it has real subjective experience, actual consciousness. But others believe that if a system behaves as if it understands, maybe that's all that matters. Searle's argument directly challenges a popular theory in cognitive science called functionalism. Functionalists argue that what matters isn't what a system is made of, but how it functions. In other words, if a system processes information the same way a human brain does, then it is intelligent, regardless of whether it's made of neurons or silicon. But Searle rejects this view. His theory, called biological naturalism, says that true understanding and consciousness can only emerge from a biological brain. He argues that minds aren't just about processing information. They require a biological, physical substrate, like neurons and brain chemistry. So even if a machine behaves exactly like a human, Searle would say it's still just an imitation, not the real thing. This is why he believes AI will never truly think or understand, because intelligence isn't just about structure, it's about the biological processes of the brain. The Chinese room argument has fueled some of the most heated debates in AI research and philosophy of mind. And now, with AI models like ChatGPT, the debate is more relevant than ever. Are these models thinking, or are they just really good at faking it? If intelligence is just about behavior, then maybe AI is intelligent. But if intelligence requires true understanding and consciousness, then AI might never cross that line. So, after exploring the Chinese room argument, let's take a moment to reflect on the key points. First, we learned about the Chinese room experiment. It's not just a philosophical idea. It's a powerful challenge to the concept of strong AI. And that's the core distinction we explored. Syntax versus semantics. Syntax refers to following rules, like a computer processing code. But semantics is about understanding meaning, something only humans or conscious beings can do. But this raises the big question. Can we ever bridge the gap between syntactic processing and genuine semantic understanding? Can machines ever move beyond just following instructions and develop true consciousness or intentionality? Is it possible for a machine to have a mind of its own, like we do? So whether AI will ever achieve true understanding remains one of the most fascinating and unresolved questions in philosophy and technology. The Chinese room argument pushes us to think critically about what it really means to know something and what separates us from machines. The conversation is just beginning, and it's one that will shape the future of AI consciousness and what it means to be alive. Thanks for joining the discussion today. Let's keep these questions in mind as we continue exploring the mysteries of mind and machine. So what do you think? Can a machine ever really understand language? Or is it just a sophisticated symbol processor? Let us know in the comments. Like, share, and subscribe for more mind-bending ideas.